Hi, my name is Nirmal Raj. I'm an assistant professor here at the Center for High Energy Physics at the Indian Institute of Science. And my research is at the intersection of particle physics and astrophysics, going by the name of astroparticle physics. And in particular, I and my students and postdocs focus on the problem of dark matter. So I have built models for dark matter, devised experimental signatures for dark matter. I work closely with experimentalists, although I call myself a phenomenologist or a theorist. And in the past, I have worked on topics such as supersymmetry, the electroweak scale, Higgs mechanism, new forces in nature. I worked a lot on collider physics, and I've taught the particle physics course a couple of times using all my research experience on these topics. Okay, so what is particle physics? Particle physics is the study of nature at its most fundamental level. So it is the study of discovering new principles in physics in terms of concepts and symmetries and theorems and so on. In short, it is the program of reductionism that was inaugurated by Isaac Newton, who was the first person to unify disparate looking phenomena in terms of a few concepts and principles. And this program is so important that in the modern era, 35% of Nobel Prizes go to the field of particle physics. Now, in this course, we will unite two very important principles that we discovered at the beginning of the previous century, quantum mechanics and relativity. And this will be put together in the form of quantum field theory. And from that, we are going to understand the world of particle states that constitute the microscopic world. So we will explore modern particle physics in this course in the following way. So we will begin by inspecting the role of symmetry in discovering new principles. We will look at how symmetry stabilizes many particle states, and then we will study the role of discrete symmetries like charge conjugation, parity, time reversal, and various combinations of those. And once you get warmed up with that, we will move on to somewhat more complicated symmetries like gauge symmetries. Okay? And when we get there, we will slowly start putting together the principles of relativity and quantum mechanics, and I will introduce quantum field theory. You don't need to know it beforehand. There will be a gentle introduction to quantum field theory, and then we will incorporate gauge symmetries into the field theory language, and this way we will slowly build up to the standard model of particle physics, which is the best microscopic theory we have today to describe the macroscopic world. So we will basically start constructing the standard model and end that module with the Higgs mechanism, which is how all elementary particles acquire mass. Once we are done with that, we will break the symmetries that we've used to construct the standard model and basically deconstruct the standard model and see what phenomena arise from the breaking of the symmetry. So we will talk about flavor physics, and we will talk about neutrino physics and neutrino oscillations and so on. And once we are done with deconstructing the standard model, we will move on to experimental observables. And in particular, we will focus on observables in particle colliders and accelerators. So that is a very important part because it's the experimental observables in colliders that validate all our theories that have gone into building the standard model. So we will look at collisions, we will look at things like cross sections and decay rates, and finally end with breaking protons through deep inelastic scattering and see what are the constituents inside a proton. And along the way, we will also see why so many people in particle physics got the Nobel Prize in the process of constructing and deconstructing the standard model. So now that you know what this course offers, I want to give you a little bit of advice, which is to not just watch the video as you come along the course, but to actually watch it with a piece of paper and a pen and follow along by writing down the calculations, because this course is going to be a bit theoretical. There's going to be a lot of matrices and contractions of indices and things like that. So there are a few moving parts to keep track of. But believe me, it's not hard at all. Once you know how to calculate these things, it's a lot of fun. And also do your assignments regularly and revise the material as regularly as possible. So I hope to see you in the lectures and hope it's fun for you. Thank you.